H means change in enthalpy. Enthalpy of the reaction. Now you will know what is enthalpy of the reaction or enthalpy change of reaction. It is the amount of heat given out or absorbed during a reaction at constant temperature and pressure, and it is denoted by delta H, change in enthalpy or enthalpy change. When a reaction happens, some energy given out or some energy absorbed. That amount of energy is known as enthalpy of the reaction, and enthalpy of the reaction is denoted by delta del H. This means heat of the reaction or enthalpy of the reaction. Now you see, nitrogen reacts with hydrogen. When nitrogen reacts with hydrogen to produce NH3, NH3 means ammonia. This reaction when happen, negative 92.4 means 92.4 kilojoule energy is produced. So this 92.4 kilojoule energy is known as enthalpy of the reaction or heat of the reaction. Enthalpy or energy, same thing. So now what is the enthalpy of the reaction? When a reaction occurs, some energy is absorbed or some energy is produced. That amount of energy is known as enthalpy of the reaction or heat of the reaction. Now you will know what is exothermic reaction. The reaction exothermic reaction, the reaction in which heat energy is given out or produced. Given out means produced or released, is called an exothermic reaction. The reaction in which heat energy is given out or heat energy is absorbed, that reaction is known as exothermic reaction. You know, for this reaction del H value is negative. I mean, for exothermic reaction delta H value will be always negative. So what is exothermic reaction? The reaction in which heat energy is given out or produced or released, that reaction is known as exothermic reaction. For this reaction del H value is negative. So you see, nitrogen reacts with hydrogen. These are the reactants to produce NH3. This is the product. So in this reaction 92.4 kilojoule energy is released. So this is, as energy is released and delta H value is negative, so this reaction is an exothermic reaction. Now you know what is endothermic reaction. The reaction in which heat energy is absorbed or taken in is called an endothermic reaction. The reaction in which heat energy is absorbed or heat energy is taken in, that reaction is known as endothermic reaction. Heat energy absorbed or taken in. And for this reaction del H value is positive. So when you calcium carbonate, if you supply heat, this break down to produce calcium oxide and carbon dioxide. For this reaction 222 kilojoule energy is needed. So as del H value is positive, so this reaction is known as endothermic reaction. So you learn, if delta H value is positive, that means that reaction will be exothermic reaction. I mean delta H value is negative, that reaction will be exothermic reaction. I mean heat is produced. If delta H value is positive, that reaction will be endothermic reaction. I mean heat energy is absorbed. Okay, now I will discuss energy level diagram or energy profile diagram for an exothermic reaction and endothermic reaction. This diagram is known as energy level diagram. Now first one, you see this y-axis, this is known as enthalpy or energy, enthalpy, and x-axis progress of reaction, or you can write course of reaction, or you can write reaction path, progress of reaction, course of reaction, or reaction path, and y-axis is the enthalpy. Now here enthalpy value 1, 2, 3, 4 is increases, and their reaction is going on, progress of reaction. First, this is reactant. Reactant surmount this area and go to the product. This is reactant. Left hand side is reactant, right hand side is product. And you see here product has less energy up to this energy, reactant has more energy. And if product has less energy than the reactant, that reaction will be exothermic reaction. If product has less energy than the reactant, you see product has energy from this to this, but you see reactant has an energy from this to this, and product has only this. This is product, this is reactant. So in exothermic reaction, product has less energy than the reactants. And for endothermic reaction, you see product has more energy because product is from this to this, reactant only from this to this. In endothermic reaction, product has more energy, reactant has less energy. I mean, if product below, that will be exothermic reaction. If reactant below, that will be an endothermic reaction. Clear to you? Now we will know what is activation energy. Okay, now you will know what is E-act. E-act means activation energy. Activation energy or enthalpy. What is activation energy? To start a reaction, the minimum amount energy is required is called activation energy. That means reactant go to product, so reactant must have to surmount this area. That means this is the peak of the curve. The energy difference between reactant and peak of the curve, this is known as activation energy. To start this reaction, this energy is must needed. If reactant has less energy than this energy, reaction will not happen. So what is activation energy? The energy difference between reactant and peak of the curve, this difference is known as activation energy. Here, this also reactant and peak of the curve, the energy difference is known as activation energy, E-act. Now what is enthalpy of the reaction? Del H. Del H means enthalpy of the reaction. This is reactant, this is product. The energy difference between reactant and product is known as enthalpy of the reaction, and this will be downward arrow and delta H value will be negative. Why? This is an exothermic reaction, and you already know for exothermic reaction delta H value is negative. So the reactant and product and energy difference is known as enthalpy of the reaction. Here also same, this is the reactant, this is the product. This difference is known as an enthalpy of the reaction, but this is positive. Why? For this is an endothermic reaction. You know, for endothermic reaction delta H value will be positive. So this upward arrow endothermic, downward arrow exothermic. Enthalpy y-axis, x-axis progress of reaction or course of reaction, or you can write here reaction path, or you can write x-axis reaction path. PATS path. This is the first one is energy level diagram for exothermic reaction, and second one also energy level diagram for endothermic reaction. This is figure exothermic reaction, this is endothermic reaction. Reactant goes to product, reactant above, product below. This is exothermic reaction. Reactant to peak of the curve distance is known as EACT, activation energy, and reactant to product distance is known as enthalpy of the reaction, and this is negative for exothermic reaction. Second one is, this is the endothermic reaction, and this reactant goes to product. Here reactant has less energy, product has more energy. Now reactant to peak of the curve distance is known as EACT, activation energy, and reactant to product, this distance is known as del H, enthalpy of the reaction or change in enthalpy, and this will be positive because this is an endothermic reaction. Okay, now you will see an energy profile for burning of methane. Burning means reaction with oxygen, and you see methane burn in oxygen or reacts with oxygen to produce carbon dioxide and water, steam. This reaction is minus del H value is minus 92.4. That means from this value we can understand that this reaction is an exothermic reaction. I means during this reaction 92.4 kilojoule energy is released, produced, given out. Okay, now this diagram, as it is exothermic reaction, already you know reactant has more energy, reactant has more energy from this to this go to, and then product has less energy. This is a diagram, and this left hand side you write reactant, all reactant. Here methane and oxygen, there are two reactants, and this is the peak of the curve, this upward arrow, activation energy, and activation energy you already write. Then this is the product, right hand side is product, so I write here carbon dioxide plus water, and this upward arrow, activation energy. Now you see this is, as del H value is negative, so this is an exothermic reaction, and reactant and product, this downward arrow, reactant and product distance is known as heat of the reaction. I mean this is the delta H, and its value will be minus 92.4 kilojoule per mole. Y-axis enthalpy or energy, unit kilojoule, and progress of reaction x-axis, or you can write reaction path or progress of reaction, or course of reaction also you can write. This is the energy level diagram for combustion of methane. This diagram is exothermic reaction because product has less energy up to product, and this is the reactant. Product has less energy, reactant has more energy. So this reaction is an exothermic reaction. Reactant to peak of the curve distance is known as activation energy, and reactant, this is the reactant, this is product distance. Reactant to product, this is heat of the reaction or enthalpy of the reaction. Let's move. Okay, now you know some reactions are called exothermic reaction and some reaction are called an endothermic reaction. Why? Here I write here one. When methane combustion with oxygen methane burn in oxygen to produce carbon dioxide and water, and this is an exothermic reaction because delta H value negative minus negative 818 kilojoule. So question is asking you why this reaction is an exothermic reaction. I mean this reaction, why heat energy is produced. Exothermic reaction means heat energy is produced, and for this delta H value will be negative. So now you are asking why this is an exothermic reaction. And you know, in a reaction, left hand side is called reactant and right hand side is called product. Yes, left hand side reactant and right hand side product. And you also know in reactants bonds break because reactant react. When reactant react, bonds break, bonds are broken, and bonds break, then reactant react, product, you will get product. In product, bonds are formed, bonds are produced. So you know, to break reactants, to break something, you know, energy is needed. And when you made something, when new bond form, energy is released. So now you see, in reactant, I mean this is the reactant, bonds are broken, and for this energy is needed. In reactants, bonds are broken and for this energy is needed. To break these bonds, energy is needed. Now this is the product. In products, bonds are formed, bonds are produced, and for this energy is produced, released. When bond form, energy is produced. So this need, this produce, this need, this need energy, this produced, produced, produce. So why this is an exothermic reaction? In this reaction more energy is produced than needed. Produce more, need less. So extra surplus energy given out. For this reason this reaction is an exothermic reaction. To break bonds, energy is needed. To form bond, energy is produced. In this reaction, need less, produce more. So extra energy is released. That's why this reaction is known as exothermic reaction. In this reaction, more energy is produced than needed. Need less, required less, but produce more. So extra energy is released. That's why this reaction is known as exothermic reaction. Now see second one. When nitrogen reacts with oxygen, nitrogen 2 oxide or nitrogen monoxide, and this is delta H value plus, that means this is an endothermic reaction. So now question is asking why this is an endothermic process or this is an endothermic reaction. Why? As you know, in reactant, this is the reactant. In reactants, bonds break. For break bond, energy is needed. And in product, bonds are made. For making bond, energy is produced. In products, bonds are formed and energy is produced. But this is endo. I mean, endo means this energy is needed. Delta H is positive. So why endo? In this reaction, more energy is needed than produce. Produce less but need more. So extra energy is needed. More energy is needed. Produce less, need more. That's why to occur this reaction, we have to supply more energy or more heat. For this reason, this is an endothermic reaction. So why this reaction is an endothermic reaction? You know, in reactants, bonds are broken and for this energy is needed. And in products, bonds are formed or bonds are made and energy is produced. In this reaction, more energy is needed than produced, than released. For this reason, this is an exothermic reaction. Thank you, dear students. Please subscribe, like and share my channel. Thank you everyone.